let's start. Good afternoon. Today I'm going to present about PoseGPT chatting about 3D human pose. This paper was published in arXiv in 2023. So PoseGPT is proposed to add ability to multimodal large language model in understanding human pose from the input text or image. So PoseGPT embed a human pose through pose embedding within a large language model to directly generate a human pose from input text or image. So PoseGPT not only simplify the human pose, but also empowers the large language model in understanding and reasoning about human pose. So for the Lava, was introduced in vision instruction tuning purpose that they try to allow the input text or image to make a communication between text and large language model. So as you can see the architecture here, Lava accepts text and image as input. If the text image input is sent to Lava, it's gonna be sent to Vision encoder, which is frozen, and then it's gonna estimate the feature from the image, and then it connects with the language embedding through the trainable projection weight here. So it can make a communication between text and image and produce a useful text output. So as you can see the sample here, when the user asks Lava to describe the question here, the question would be what is the ending of the movie. So Lava would have to understand what is the input image, and then they try to use the well knowledge of the large language model to return a useful answer for the question. Similarly, there's a verb called Lisa, which is used large language model to output a text along with a segmentation mask. So the architecture is similar to the previous one, but they try to adapt a new feature to large language model to estimate a segmentation mask. So Lisa accepts both image and text as input, and then the text and image is sent to the frozen multimodal. And then this model is fine-tuned using a LoRa, which is a efficient fine-tune measure that I'm going to describe in the next slide. So the large language model will output the sequence of text, which the last token is belonging to segmentation mask token. And this token will send to segmentation mask decoder, along which they encoded feature from the input image to generate a segmentation mask. So as the large language model has a knowledge about the vitamin C food here, so it can output a segmentation mask on the apple. So this is the sample of the communication between users and Lisa. So the user asked Lisa to segmentation, a person that was the former of the president of United States. So Since Lisa has the well knowledge about the person that was the president of the United States, it can output Barack Obama for the segmentation task. So this is the LoRa, a fine-tuning method for large language model. So instead of fine-tuning the pre-trained with when it is asked to fine-tune or to add a new feature to the large language model, LoRa, it depends on the delta W, which is the product of matrix between A and B, which the matrix A has the dimension of R by D and matrix B has the dimension of D by R. So if we compute the total parameter of each weight, we can see that if we fine-tune the large language model with the pre-trained, the number of parameters would be D by D. But if we try to fine-tune only the delta W, the total parameters of pre-trained large language model would be 2 A and D. So we can see that LoRa used only a fewer parameter for adding a new scale to the large language model. So it can reduce the computational cost and also makes the adding new scale ability become more easy. So this is the architecture of PoseGPT. It uses large language model to estimate the 3D pose. So PoseGPT accepts both image and text as input. If the image is sent to PoseGPT, a frozen vision encoder gonna extract the visual input and then send it to a large language model. For the large language model, they are using Lava version 1.5 with 13 billion parameters, where the cliff image encoder is frozen, and then they use Vicuna 13 billion parameter for the large language model. And this Vicuna is frozen and fine-tuned by using LoRa with a lower rank as equal to 126. So during the training, LLM will output the sequence text, and then for the last token of the output text, it is belonging to the host token, which is will be sent to a SMPL projection to produce a host parameter. And for this task, they set the sub parameter equal to 0 because they think that their task doesn't be trying to estimate the average self of people. Here the sample of communication between people and the PoseGPT. So the input can be text or text along with image. If image is provided, they're gonna output a post. And Lisa, PoseGPT also providing the answer about the text. As example here, we're trying to know what is the context in image. So instead of only providing the post as an output, PoseGPT also providing the answer according to their well knowledge. So for the loss calculation, they try to calculate the loss between the predicted text output and the ground truth text. If the PoseGPT is asked to estimate the 3D human pose, they also calculate the L1 loss between the output 3D pose within the ground truth 3D human pose. For the weight of the text, they set it into 1, and for the weight of the post, they set into 1.0.1. So in order to train PoseGPT, they're trying to involve with some techniques. First of all, we have the text-to-post generation that this can represent as a pair of description text with a human post. So in order to fit this to the PoseGPT, they adopted the template here, which uh, can allow the PoseGPT to understand the conversation between a human and PoseGPT. So the description here can be retrieved from the data set. For this text-to-post generation, they use the PostScript data set. And for the human post estimation, they trying to collect the standard data set of human post estimation, and then it can be represented as a pair of input image with output human post. And then this is the template to make a communication to PoseGPT. So the image here is received from the standard data set from human post estimation, and then the output post. And for the task to allow human to ask for the human post through the chat communication, they trying to adopt the multimodal instruction following data set called Lava version 1.5 makes 665K dataset to create a new dataset for training PoseGPT. In order to evaluation PoseGPT, they also involved with a spectacular still generation task. This task require user to ask a implicit description for the post generation. So because of they are using the PostScript dataset, so the description would be very explicit. So in order to make model produce a good result in estimate human post, the description should be in implicit. For this task, they use the description from PostScript, and then they ask GPT-4 to reform it into the implicit version. So as you can see here, the text in green are the text from PostScript, which is very explicit, but through the help of GPT-4, it can be used the implicit version. This is the table showing the result of retrieval recorded between PostScript and the new spectacular still post generation benchmarks. As you can see here, for the speculative post generation benchmark, PostGPT can obtain a better value compared to PostScript. And the other task for evaluation PoseGPT, it is a reasoning-based post estimation, for this task, it can allow user to specify specific query before asking the PoseGPT to generate a human pose. So as you can see here, user might be asking the PoseGPT to generate a human pose for the man with a black hair. In order to get that evaluation data set, they collect the data from standard human pose estimation and then extract the 2D key point from the image before sending it to the GPT-4 version to output the specific description of the input image. Here the result of comparison between reasoning-based pose estimation with different text description. They also report the MPJ-PE, also the other method. As we can see, the PoseGPT can often a good result in PA, MPJ-PE, and P MPJ-RA value, but they cannot achieve a good result on MPJ-PE if we comparing to the traditional human estimation method. So to generalize the PoseGPT in question and answer, they also create a template which is can provide a more diversity for PoseGPT in understanding human pose and responding to the person. So as we can see, instead of answer it as it is a post, they provide different text as output. And they also can accept different question to PoseGPT. For evaluation, they also conducted an evaluation on 3D PW dataset and human 3.6 million dataset. So as we can see, PoseGPT can allow a large language model in estimate a 3D human pose. But if we compare it to the standard human estimation method, we can see that it cannot provide a good result yet. And this is the demo of using PoseGPT to generate a 3D human pose from input image. They can provide a 3D human pose as the result. So in conclusion, PoseGPT can allows the large language model to be fine-tuned to estimate 3D human pose, and also it can connect between human and language for the communication. And it is a new use case where user can chat with large language model. Even though they can estimate the 3D human pose, but there's still limitation to the providing a good accuracy. So that is for my presentation. Thank you. Is there any question? Stop the share. Did you stop it? Okay.